Late one night in 1961, Betty and Barney Hill were driving through the remote New Hampshire countryside when their peaceful journey took an eerie turn. A strange light appeared in the sky, followed by a missing time experience that left them with haunting memories. Their encounter was just one in a long line of mysterious UFO sightings, sparking a worldwide frenzy of questions. What if we're not alone in the universe? What if something is out there, watching us? Fast forward to today, UFOs still steal the headlines, and the search for life beyond Earth is far from over. The universe doesn't reveal its secrets with flashes of light or sudden encounters. Instead, it whispers them through faint, elusive clues we call biosignatures. These subtle signs might be the key to answering the question that has haunted humanity for centuries: are we truly alone? So what exactly is a biosignature? Think of it as the universe's hidden footprints, chemical or physical signs hinting at life. When scientists use powerful telescopes like the James Webb, they look for odd gas combinations. Certain gases in unusual amounts could be our first sign of alien life. Gases like oxygen, methane and nitrous oxide are prime suspects, produced by life's processes. In a planet's harsh environment, these gases shouldn't linger in large amounts. Take oxygen, for example. If we spot a planet with a significant gulp of oxygen, that's intriguing, because on our Earth it's life plants, algae, the whole green symphony of photosynthesis that constantly exhales oxygen into the atmosphere. Without life constantly replenishing it, oxygen would vanish quickly, locked away in reactions with rocks and the planet's surface. Similarly, consider methane. It's another gas that can raise eyebrows. Large amounts of methane, especially when found with oxygen, that's a stronger hint that something biological might be at play. Maybe vast, hidden colonies of microbes exhaling methane as they go about their mysterious and fascinating microscopic lives. And then there's nitrous oxide, another atmospheric gas that has astrobiologists on the edge of their seats with excitement. Our search for life's fingerprints isn't just about finding odd gases in a planet's atmosphere. Scientists also look at isotope patterns. There are different flavors or isotopes of carbon. Two of the most common are carbon-12 and carbon-13. Carbon-13 is slightly heavier because it has an extra neutron. Living organisms prefer using the lighter carbon-12 during photosynthesis and other metabolic processes, as it takes less energy to handle. For example, on Earth, if you analyze organic matter like plant material and compare it to non-living sources such as volcanic rock, you'll see a higher ratio of carbon-12 to carbon-13 in the organic matter. This skewed ratio hints that life was involved. If we found that same carbon isotope ratio in a rock sample from a distant planet, it would strongly suggest that some form of biology, no matter how simple, once existed there. Next, there are specific chemicals like complex organic molecules. Think of building blocks like amino acids or fatty lipids. So complicated, they're unlikely to appear without living organisms creating them. Life can also leave its mark on minerals, shaping them in ways that plain old geology rarely ever does. For example, certain microbes can grow crystal structures that look refined or arranged in repeating patterns, not by chance. Microscopic structures, possibly fossilized bacteria, show tiny cells in rock indicating ancient life. And on a larger scale, you've got stromatolites, layered mounds of rock built over many centuries by microbial communities. Sometimes scientists observe a planet day after day or year after year, and they start noticing the levels of certain gases spiking or dropping. If these changes seem too big or fast for ordinary geological processes, it suggests something else might be driving them, potentially life. This is what scientists call temporal variability. It's like catching the planet in the act of breathing or metabolizing. Then there's surface reflectance, which is how a planet's surface bounces light back into space. Certain living things, like plants on Earth, have special pigments, chlorophyll for example, that reflect light distinctly, creating the red edge. If you split the light from the planet, you'd see a jump in reflectance at red to near infrared wavelengths, hinting some organism is using those pigments for energy, like plants do during photosynthesis. Finding these patterns elsewhere would be like spotting a glowing sign saying, "Life is using light here." Now here's the crucial challenge. The search for biosignatures is not without its hurdles. One of the biggest is the possibility of false positives. Detecting something that looks like a biosignature doesn't automatically mean we've found life. The universe is complex, and non-biological processes can mimic signs of life. In 2020, scientists detected phosphine gas in Venus's atmosphere. On Earth, phosphine is primarily produced by microorganisms, sparking excitement about potential life in Venusian clouds. However, further research suggested phosphine could be produced by non-biological processes like volcanic activity. Volcanoes, for instance, release gases like methane and phosphine. This ongoing controversy highlights the difficulty of interpreting potential biosignatures and the need to consider all possible explanations carefully. Let's take another example of Mars and Venus. Mars has traces of methane, likely geological in origin. Venus has carbon dioxide, but due to a runaway greenhouse effect, not life. These planets remind us that a single clue might be misleading, and so scientists are shifting focus from single biosignatures to biosignature ensembles, which pieces multiple clues together to paint a clearer picture. Now, if you're wondering how we actually hunt these cosmic breadcrumbs, say hello to the James Webb Space Telescope, which is currently scanning the skies with an uncanny level of precision. JWST is revolutionizing our understanding of exoplanet atmospheres, detecting a wider range of molecules with unprecedented precision and detail. But it's not just about telescopes. Closer to home, NASA's Perseverance rover is prowling around Mars, hoping to catch ancient microbes in the act, or at least their fossils. Then there's Europa Clipper, set to explore Jupiter's icy moon Europa and its hidden ocean, and Dragonfly, destined for Titan, a place with lakes of liquid methane hydrocarbons. One day, bigger telescopes might let us photograph Earth-like worlds and analyze their atmospheres in detail. The thought of discovering alien life is both thrilling and unsettling. Stephen Hawking warned that advanced civilizations might not be friendly, while Carl Sagan believed we must explore space to survive cosmic threats. Finding life, whether a distant civilization or simple microbes, would revolutionize our understanding of biology, evolution, and consciousness. So, next time you gaze at the night sky, remember that each star could hold clues waiting to be uncovered. If you enjoyed this exploration, don't forget to like and subscribe for more cosmic journeys.